In this video, we'll be learning about increasing, decreasing, and periodic sequences. Most important part of this video is about periodic sequences, but we'll have a look at them everything anyway. So, what are increasing sequences? Increasing or decreasing sequences are also known as monotonic. If you study further maths, they call them monotonic sequences. Alright, so what's an increasing sequence? Basically, if the next term is bigger than the current term, that's increasing. And if the next term is smaller than the current term, that's decreasing. We'll look at periodic sequences in a minute. Let's just see an example. So we've been given this formula, un plus 1 is un plus 3. So if you substitute and generate the numbers for this sequence, you get 7, 10, 13, and so on. It's not hard to see that it's an increasing sequence. Okay, so if you've been asked to prove it in an exam, all you have to do is generate the first few terms and write for the examiner. And here, this capital N notation stands for numbers, natural numbers. Natural numbers start with 1 and continue up. You count with natural numbers. Alright, so let's look at another example. In this next relation, you have un squared to give you the next term. So, and the first term of the sequence is a half. When we substitute a half into the formula, we're going to get a quarter. And then the square of a quarter is 1/16, and so on. What do you think? Is it an increasing, decreasing, or periodic sequence? This is obviously a decreasing sequence. The numbers are naturally getting closer and closer to zero. The asymptote would be zero, but actually they would never reach it. We have them. This is a monotonic sequence. They are decreasing. Alright, let's look at another example. So we've been told that the next term, this current term of the sequence is 90 times n, and we take that and put it in sine function. So n starts counted with 1. Okay, you can assume that you substitute 1 for n. And how do we generate these actually? If you substitute 1 here, and if you consider the sine curve, what we get is sine of 90 to be the first value, because 90 times 1 is 90. So sine of 90 has a value of 1, doesn't it? So, and when you substitute 2 into the sequence, you're going to get sine of 180. Sine of 180, or 2 times 90, is simply 0. And the next term would be negative 1. So we start with positive 1, we went down to 0, and the negative 1. And the fourth term would be sine of 360. Sine of 360 is 0 again. So the sequence would be going up from 1, 0, minus 1, and to 0. And what do you think the fifth term would be? The fifth term would be a copy of the first term again, because this is a circular. What we did is we went around the circle. The first term started here, the second term took us here, sine of 180, then we got sine of 270, and then the fourth term took us back to where the 0th term was. And the fifth term would be where the first term is. So it's not hard to see. This is called a periodic sequence because it has a period and it will repeat itself. It's not just sine function that will give you a periodic sequence. It may be cosine or some other function. Okay, so Sometimes you will be asked to calculate the sum of certain number of numbers. For example, let's say you've been asked to calculate the sum of first 200 terms in this sequence, where we got sine of 90n. How would you answer that? Pause the video and have a go at it, and then play the rest of the video and we'll look at it. Alright, well done if you have had a go at this. The the sum of the first 200 terms, it would be, you would repeat this pattern 50 times, because 200 is basically 4 lots of 50, and sum of one period is 0. Therefore, if you times 0 by 50, you still get 0. So that's the trick. You just have to be careful. Sometimes you have a leftover. For example, they may have asked us to find the sum of first 201 terms. So you would do the same trick. You would say, okay, my first 200 terms have sum of 0, but the very last one will have sum of 1. Okay, so that's the answer. Alright, I hope you found this video helpful. I'll see you in the next video.